Hello, students. A couple questions out of 6.1 come in for the MCs, questions 8 and 9. So I'm going to go ahead and address those. So 8 and 9, let's see if I can roll down just a little bit more on the page. So 8 is, I guess it's kind of at the top. Maybe if I zoom in a little bit and roll down. There we go. Okay. So 8's up here at the top. We'll just kind of go 8 and then 9. So this question, let's get some white space here for number 8. Okay. What fractional part of the two pizzas did this person eat? So I think for this one, this is kind of a little bit of thinking about pizzas being cut. And it says they're being cut. Each one is cut into 8 equal-sized pieces. Now they're equal sizes. So even if I don't draw a perfect picture here, this would be 2 equal sizes. There's 4. And every time you cut them in half, you get equal-sized pieces. So this is what it would look like. Each one of these pieces would be 1/8 of the entire. So when you're looking at a 12-inch pizza, to be perfectly honest now, I have to think a 12-inch pizza is typically 12 inches all the way across, which would be the diameter. So the radius of that pizza would be 6 inches. And that again, let me come over here and kind of make my pen a little bit thicker. This right here is the radius. So that would be a radius of 6 inches. Okay, so now the total amount of, when it says the fractional part of the two pizzas, they're really saying how much of the whole pizza did you eat? So we're going to use the area to represent kind of how much area would be represented here. The area of a circle is pi r squared. So for this one, the smaller pizza, we would use pi times 6 squared. Okay. And so this would give us 36 pi square inches. So that's how much kind of area there is. Now, technically there is a volume, but we'll have to kind of assume that the pizza's uniform thickness. So the volume piece won't really make a difference here. So there's that. Now remember, she took one piece, but we had cut it into 8s. So what we really have is for the small pizza, we had a total of 36 pi square inches, but she took 1/8 of it. So I'll just divide it by 8. Then we have the large pizza, and the large pizza would be an 18-inch pizza, which again would be a radius of 9 inches. And so doing the same thing, pi times 9 squared would be 81 pi over 8. Okay. So if we add these together, they're all over 8. What we end up with is 36 pi plus 81 pi, and those are like objects, so we can add them together. So we get 117 pi over 8. So that's the fractional part of the two pizza. That's the fractional amount that she ate. Now remember, the total here is out of all of the area combined, which would just be the stuff that's in the numerator here. And so if you add these together separately, you get the 117 pi. So this is the total. So you want to know what part she had out of the total. And what we could say is, her part out of the total would be 117 pi eighths out of 117 pi. Now, again, if you want to do the division here, you can rewrite this. So you end up with 117 pi divided by 8 times 117 pi, and your fundamental law of fractions comes in, and this entire chunk goes away, and your final answer would be 1/8. Now, this would be a very different problem if she ate one piece of the small and 2 pieces of the large, because now it's not the same. But there is, of course, a shorter way to do this. I want to show you all the math that shows how to get to the full fractional piece. But if you just look and said, she took 1/8 of the small, and then she also took 1/8 of the large. So when you put that together, even right here, if you were to factor this out, this would be 1/8 of the total, if you were to factor that out. And so if you just kind of brought this down here, you could say it's 1/8 because each one has a 1/8 of 36 pi plus 81 pi. And really, this right here is the total. So Becca ate 1/8 of the total by eating 1/8 of each individual piece. Again, demonstration of the distributive property in action, but also a demonstration of, hey, there could be some higher level math, but it might be kind of a quick way to get there as well. So yeah, let's take a look now at number 9. For this one, maybe I won't go all the way through, but it says, how would you show 1/4 of the combined area? Now, the combined area in your mind, you're kind of thinking, I have to push this one together, and kind of just sketch one object, but it does say combined area. So what you could do, I'm going to try to switch over to just drawing a straight line and see if this works. Woo! Is right here, if I cut each one of these objects in half and I shaded this piece right here, I would be shading 1/2 of the combined areas. So my hint to you is that I just showed how to do 1/2 of the combined areas. The question is asking you to do 1/4 of the combined areas. Number of different ways to do this. So I want to leave that with you as a nudge in the right direction. Okay. So there is 8 and 9, and hopefully that gets you on the right track. All right, off you go.